Hello everyone, welcome to SWAM course on image processing using Python. My name is Dr. Bharti Patel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. So let's start the today's session. I am going to present the culmination of our journey through the world of image processing using Python. So today I will discuss some of the important areas where we can see the vision of image processing, or we can say it is almost everywhere. So some important applications are as follows. First is listed with medical image analysis. In this area, we can analyze tumor detection in MRI scans. With deeper understanding of developing an algorithm to identify and classify tumors in brain MRI scans. Second one is facial recognition for access control. In this, we have to see that how we have to create a system that uses facial recognition to grant access to secure locations. Next application is automated number plate recognition, or we can say ANPRI. So in this, building a system that can detect and recognize vehicle license plates from images or video streams. Some other applications like satellite image analysis for agriculture, which is going to develop a tool to monitor crop health, predict yield and detect pest infestation using satellite imagery. Then the next application is gesture recognition, which is creating a system that can recognize and interpret hand gestures for controlling devices or interfaces. Next application is document scanner and ORC, that is very old application. So in this, building an application that captures an image of an document and corrects distortions and extract text using OCR. Next application is dental X-ray analysis. In this, developing a tool to identify dental issues such as cavities or abnormalities in X-ray images. Then the next one is automated quality control in manufacturing. In this, building a system that detects defects or deviations in manufactured products using image analysis techniques. Next application is, which is very important, emotion recognition in images. In this, creating a system that can recognize facial expressions and emotions from images or video streams. Then object tracking in videos. In this, developing a system that tracks specific objects or individuals in a video stream. Then in continuation to this, next application is food recognition and calories estimation. In this, building an app that can recognize different types of food from images and estimate their nutrition content. Then the next application is traffic sign recognition for autonomous vehicles. In this, creating a system that can identify and interpret traffic signs to assist autonomous vehicles in navigation. The next important application is handwritten digit recognition, that develop a digit recognition system that can accurately identify handwritten digits. The next important application is real-time lane detection for self-driving cars, which is going very fast nowadays to implement a self-driving cars. So in this, creating a system that can detect and track lane marking in real time to assist autonomous vehicles. Next is virtual try-on for fashion retail. In this, building an application that allows users to try on clothes virtually using images or videos. Then the next application is art style transfer. For this, creating an app that applies the style of a famous painting to a user's uploaded image. Then the next continuation of the application is sentiment analysis from social media images. It developed a system that can analyze images shared on social media platforms to understand sentiments. After that, image forgery detection. It means that develop, or we can say building a tool that can identify manipulated or fogged images. Augmented reality filters. This is also a kind of application for AI. So in this, creating a custom AR filters for social media platforms that can overlay virtual objects or effects on live video. Plant disease detection in agriculture, which is very important nowadays. So in this, developing a system to identify diseases automatically in plants based on image of their leaves or roots, or we can say any of the part of the plant. So these projects demonstrate the practical applications of image processing across various industries and fields. So they provide opportunities to solve real world problems, which is our main target. So innovate and make a positive impact using Python and image processing techniques. So out of all the presented applications, here we can say that I have chosen the last application, which is my own PhD work or research work. I would like to briefly discuss this research as it was recently submitted with this application. It involves rice plant image processing using Python. So with this note, let's start the project work. So first of all, I would like to discuss some of the objectives of the research work as a project which I have completed. So the research objectives are combined into 4 phases, or we can say in 4 parts. So following are the first phase A. Basically phase A define developing a model with Chhattisgarh dataset using feature fusion and decision fusion technique for automatic growth analysis of rice plant. Then the next objective, which is described as phase 2, or we can say phase B, in this designing a model for automated detection of spikelets per panicle for predicting yield production of rice plant. Then phase 3, which is called developing a model for precise evaluation of panicle based grain disease detection in predicting yield production of rice plant. Then last phase is designing a model to automate identification and disease detection for analyzing biotic traits in rice plants. So from all these phases, we can conclude, or we can say that it is basically exclusively for rice plant growth monitor, and it is covering the whole plant area. It means the leaf, root and the spikelets, panicle and overall. So it is, we can say it comes under the plant phenotyping, which is the main project for this session. So let's begin with the first phase, and we have to discuss some of the methodology and result section, that how I implemented according to the specific task and how I achieve the desired output by applying those methods. So in phase 1, we applied pixel mapping technique. What it means we have to learn. Basically, pixel mapping technique refers to a process used in computer graphics and image processing to establish a relationship between points in a source space, usually an input image we can say, and points in a destination space, or we can say usually an output display or canvas. So this technique is commonly used for tasks such as image distortion, transformation and manipulation. In pixel mapping, each point or pixel in the source space is assigned a corresponding location in the destination space. Then this mapping allows for various types of image manipulations such as resizing, rotation, wrapping and morphing. So the goal is to ensure that the transformed image maintains visual coherence and accuracy. So by this image, we can analyze that how it works, means how pixel mapping technique is worked in color images. In this image, we can analyze, first of all, we have to see that these blocks are showing our pixel collection, and out of all the pixel collections, we have to choose the particular pattern which is called a pixel mapping technique. Particular pattern we have to map according to our output requirement. Then we have to fetch that pixel combination and we have to create the output. So for first phase, I have chosen some of the real world data set from IGKV, that is called Indira Gandhi Krishi Vishwavidyalaya Raipur, and this is the image from there I have taken personally. And in this image I applied a horizontal reference based plant phenotyping technique, or we can say pixel mapping technique. In this image I have taken a reference based image which is the whole field of the rice crop, and I have taken a reference image as a scale and applied in that particular image in the position in the upper side, so that we can discriminate the length of the plant and we can analyze the average size of that particular plant, and we can say that the discrimination is showing the average height of that particular plant. So I applied this pixel based mapping technique for the whole field, or this is a great task because by this task we can get the average height of the plant overall field. So this image is showing the accuracy measurement of that particular plant. So here some sample images have been taken from rice crop 1 to 14, some of the sample images, and we applied both the technique, vertical horizontal technique. We applied both the technique, vertical pixel mapping technique and horizontal pixel mapping technique, and we compared with their pixel coordinate values and getting the output. So output is showing that how much efficient this technique is. So by this diagram we can analyze the accuracy percentage and the error difference in percentage. It means what is the actual size and what is the observed size, and we compare that how much error we have calculated by applying the technique. Obviously in vertical technique there are some manual effort, so there must be some error, but in horizontal technique we applied a reference based technique. Here we combine both the images, it means the scale and the plants, and we calculated the average height. So according to that we have captured some of the accuracy percentage which are calculated here. So this work shows vertical and horizontal plant height detection using pixel based image analysis. So the proposed method is providing an average height of every plant. So it exhibits plant phenotyping applications such as height measurement of a single and field plants by using pixel based clustering technique. In this work, scaling technique for object height calculation provide automated reference point for the difference measurement between object and background. So next phase is rice variety classification and yield prediction using semantic segmentation of agromorphological characteristics. This is the another objective. It is basically defining that how to classify, or we can say how to detect the variety of particular rice plant. So for a long time the only method for diagnosing rice variety or variety classification was through simple visual inspection. Because of this, society as a whole is compelled to consider the employment of advanced technology in order to accurately predict yield and adopt corrective measures in time. Therefore, image processing and machine learning techniques are better visualization technique for yield prediction. So we can understand the methodology of this particular method. In this diagram we can see that how the semantic segmentation works. So in this diagram we can analyze that some portion which is going to start with the input images. In left hand side we can see that the image slices are distributed in the different parts, and it is going to import for the further processing. According to that, we have decided some vertex, and it is shown here with the circle point. In that point we can analyze the pixel coordination. Our main goal is to calculate the pixel correlation so that we can analyze the object and we can identify that which variety the particular object belongs to. So this diagram is showing the input value corresponding to the output value by using semantic segmentation and hidden Markov model. So the next diagram, it is showing the hierarchical distribution of pixel that are sometimes a collection of input trained images and the segmented mask. So the input image is distributed in two parts. First one is input image itself, the original image. The next one is segmented part, and then we have to correlate both the images and we have to analyze that how much portion is actually accurate. According to that we have to correlate the pixel value and we have to calculate the output. So this is the result section of that particular variety detection. So this result shows there are 4 classes and we can say 4 rice varieties, and we have analyzed that 4 varieties according to that particular method, which is called semantic segmentation. And this is the performance comparison of the presented method, and we have taken some existed method and we compared with the existed method and we got our proposed method is accurately identify the variety. So the main benefit of the above algorithm is the setup. It provides for scheduling, training and processing based on memory bound to the support set on a timely basis. So resulting in a decomposable or expanding sequence when other instance pairs are added in relation to the previous trained hypothesis. So it ensuring that the trained hypothesis is always bounded and deducible from the other previous pairs of instances. So the training can be done in a small number of roof, that is called roof instances, while maintaining high accuracy. So next phase is detection of spikelets per panicle for predicting yield. So what is spikelets? Spikelets is called a bunch of grains which are collected with that particular spikelets. So in this we have detected a spikelet so that we can directly calculate the production growth. So in this we use binarization technique which is commonly employed with artificial intelligence. Image binarization is the conversion of document image into bilevel document image. Image pixels are separated into dual collection of pixels. It means black and white. So the main goal of image binarization is the segmentation of document into foreground text and background, and extraction of segmented image for test image with rice spikelets, deploy binarization and vectorization to determine its spikelet per panicle. So this is the result, or we can say it is almost like a skeletonization technique, like in that we have to detect the edges of that particular object. The same as this binarization and vectorization technique is giving the same output. Here we can count the spikelets and we can clearly identify that how much production growth is there for that particular object. So in this work, 10 paddy varieties using computer vision and image processing techniques are effective in terms of progressive performance. Color, texture and pixel variations of 10 agro-morphological rice characteristics were examined using 2 different models, each with its own set of parameters. This work is also possible for the classification of wheat, barley and maize varieties from images of rice varieties. So the next phase is automatic rice plant disease diagnosis using gated recurrent network. We use machine learning techniques and deep learning techniques for that, and we implemented in the image processing technique. So in this, identification of crop based diseases from image data is a complex image classification task. So this task includes but is not limited to image acquisition, pre-processing, segmentation, feature extraction, feature selection, feature based classification and post-processing. So to reduce the effect of these system failures, these text processes are highly efficient incremental learning based transfer learning system that uses a combination of CNN and GRU models. Databases like Rice Knowledge Bank, Kaggle and the University of California, or we can say machine repository of machine learning, some of the databases are used here. So this is the proposed methodology diagram. Here we combine all the deep model techniques like ResNet 101 with GRU based BGGNet, which are already pre-trained model, and here the sections are distributed according to the input image, then the segmentation, then feature extraction, feature selection and then final classification. So this proposed transfer learning model for improved classification performance using gated recurrent unit based on CNN is very successful for this particular task. So this performance is initially tested on static dataset for which an average accuracy of calculated as 99.95% is obtained. The reason for this high accuracy is the use of multiple color spaces, which we already discussed in our previous sessions, that how color spaces are so very important. So for the representation of a single image, or we can say the group of images. So which applies to this specific application because in this case all disease types have varying color levels. Moreover, the design system is tested on 850 real-time images which vary largely in terms of disease types, and the system can achieve an accuracy of over 99%, which makes it applicable to any kind of real-time scenario. So, as a summary, we can say all these images, all these image processing methods are only when full. So, we can say all these image processing tasks are only helpful if we take the proper color space, proper technique with the proper data set. As we have seen in phase 1, phase 2, phase 3 and phase 4. All the images are calculated or have taken with the benchmark data set. Like in phase 1 we have taken our raw data. Also for that we implemented pre-processing tasks. So all the color spaces are very important to understand that which color space is going to improve the image quality and which will provide the high accuracy. So we can say in the future cross-domain disease detection models can be developed to transfer the knowledge about rice disease detection to other plant leaf diseases. We can also try to replace ResNet 101 architecture which we applied with ResNet 101 architecture which we applied with other variants of ResNet and elevate its accuracy. So thank you for choosing to be a part of this SWAM course and for detecting your thank you for choosing to be a part of this SWAM course and for dedicating your valuable time and energy to engage with the material. Your commitment to learn and self-improvement is truly commendable. I want to express my appreciation for your active participation. Throughout the course, we analyze the thoughts, questions and the effort you put into understanding and applying the concepts presented in the lectures. So, your encouragement is what makes this learning community thrive. I also want to acknowledge that learning is a collaborative effort. Your feedback, insights and contributions play a vital role in shaping the course and creating an enriching learning experience for everyone involved. So ultimately, we can say that this course is only helpful if we have real-time applications, and if you want to implement this particular code, or we can say this journey is useful if you apply your own dataset. You have to choose your own dataset, you have to create a framework, you have to make an environment. In that, you have to collect the information and then apply. So remember, knowledge is a journey, not a destination. Your dedication to expanding your horizons through education is a testament to your passion for growth and self improvement. So I have no doubt that each one of you will go on to accomplish great things. Last but not least, I would like to express my appreciation for our hard-working experts, those who have taken their valuable time and their knowledge. Dr. Atul Kumar Dwivedi, Dr. Supriya Gupta and Dr. Aradhna Sahu. Without their efforts, this course would not have reached the heights it has. So I am also grateful to our course coordinator Dr. Deepti Verma for her kind participation and encouragement throughout the journey of the SWAM course, which is an innovation platform for us. Once again, I would like to discuss some of the key points which you have to know throughout this course journey, because this is very important to know that we have to start from the starting onwards. Like the first journey or the first week journey itself is describing the concept of the course. If we have the continuation of that particular course, then we can understand that how much it is efficient and where we have to apply. Otherwise, in between, if we try to understand something, then it will be difficult for us to understand. So it is a kind of request to all of you that you have to learn from the starting onwards, because it will create a foundation for you or the base for you to analyze your own data, or we can say you can analyze in real time applications. Like we have discussed previously also, that there are lots of applications. According to that, we have to choose that what is our interest of research, or we can say what is our application in which we want to apply. So once again, thank you for being a part of this educational journey. Let's continue to learn, grow and inspire one another. So wishing you all the very best in your endeavors. Thank you.